I bought 5,000 pieces of steel to build this knife with. Little round steel spheres. The steel is 52-100, which is a good high carbon steel. With that many different little pieces to forge weld together, we need something to put them in and keep them all together. So I'm using 2-inch squared mild steel tubing with 1/8-inch thick steel plate to make end caps. These all need to be deburred and fit together into what we call a canister. There's a seam on the inside of the tubing that's going to leave a bit of a problem in our billet, so I filed that off. You'll notice the cap is inset into the tubing about 1/8 of an inch. This is important because it provides the necessary structural strength. There's going to be a lot of pressure on the inside of this canister when we squish it all together to forge weld the contents. I'm not an expert welder by any means, but we just need a decent bead to hold everything together. And there's the first cap welded onto the canister. Next thing I need to do is coat the inside of the canister with white spray paint. This is going to keep the ball bearings and steel powder from welding to the canister, and we can get it off easier. Next I'm going to use some 3/8-inch 01 tool steel rod to incorporate into our canister, so I'll need 4 of these pieces. The hacksaw was the first cutting tool that I ever used in my knife making journey. The next one was the chop saw that you saw at the beginning, which was a super upgrade and very useful. And then later on I got power band saws, which have been extremely useful as well. It's a progression, and each one makes things quicker and easier, but you can still get the job done most of the time with the simple and inexpensive tools. I tried to gauge how big the canister needed to be to fill it up completely with these 1/8-inch BBs, or bearing balls, and I didn't quite make it. Had some extra 3/16-inch bearings sitting around from previous projects, so I just filled up the remaining space. Next I'm going to fill in all the tiny spaces with powdered steel. This is 1080 steel, and it also has nickel powder added to it. With these small little bearings, the powder takes longer to work down into all the spaces. There is a small pinhole in my weld, and that is necessary, or you will create pressure on the inside of the can. It can expand, it will expand, and can explode. I just make sure that I've got a little pinhole at the last welding bit that I'm doing, and then I don't have to worry about drilling a hole in there. Some of that powdered steel on the surface is burning off out of the forge there. After making sure that the can is fully heated through, We'll use the forging press and the squaring dies to forge all of this together into one solid mass. This is repeated about 3 times, and when I'm confident that it's solid, I'll be able to take the canister off. It's not fully cool yet, but we can start on this right away and try to keep the process moving forward. You'll notice at the very end of the canister, the powdered steel didn't reach all the way to the end. Maybe I should have filled it halfway with the ball bearings, then added powdered steel, and then finished filling it up. Now that we've got the canister off, I'll be forging this down to about 7/8 inch square, and then rounding it off into a nice bar. Heating it back up to a nice high forging temperature and beginning the twisting process to put a pattern into our billet. I don't show every single twist on camera here, but I'm trying to get a nice tight pattern, so we'll repeat this process several times. When the twisting is done, we can forge the billet out into a flat representation. And then after that, we're going to have to do some surface grinding with the angle grinder to get out some minor inclusions that are always present with a twist pattern. The ends of the billet tend to be crummy, and so we'll just cut those off and not worry about it. Plus, they're not twisted either. Now that we've got a nice solid patterned bar of steel, we can begin forging the blade. And I'll start by tapering down one end, which is going to be the point of our knife. The press is useful for starting the process, and I'll finish it with the hand hammer. Before I go much further, I want to establish the tang, and again I'll use the press to forge the shoulders of the ricasso down and begin tapering the material for the tang. There's still a lot of material here, about 3/8 inch thick, and I want to widen that out for the blade we're going to build. It's going to get lengthened as well, but it's very thick right now. I need to establish the shoulder for the ricasso where it runs into the plunge line. I want the edge of the knife to drop down a little bit, so I need to forge that in before going any further. With that complete, we can begin forging in the bevel to some degree. I'm not going to go super far with it, but I do want to move some material over there. I'm leaving extra thickness here for a couple of reasons. One is I want to grind through more of the material to reveal a pattern that you're not going to see unless you grind off the surface of the material a little bit more. The blade is still nice and thick at this point, so it's pretty easy to work with and refine the profile. Some final adjustments to the tang, and we're getting pretty close to finishing the forging of this blade. There's still plenty of material to be taken off at a later point, but now we can go ahead and begin the heat cycles for this piece of steel. You'll get to see the recoalescence on this piece of steel as it cools down, a pretty neat phenomenon. And into the quench we go, hardening the steel after multiple thermocycles, and then finally we can temper it to remove a bit of hardness and add toughness to the blade. Now that it's been tempered, we can begin refining this blade, and that's started by grinding off the scale and starting to establish some flat portions on the blade, particularly near the ricasso area. I'll be using my surface grinding attachment from Beaumont Metalworks to make this blade nice and flat. I'm looking for some true flat surfaces on either side of the blade, particularly in the middle. I'm not so concerned with the end of the tang or towards the tip of the knife. Since I did forge in a bit of the bevel and a little bit of distal taper, I'm not going to fully flat or surface grind this blade. We've ground the edge and spine down to good clean steel, and using some blue layout fluid, I'll be able to make some marks on the edge of the blade and the spine to make sure that everything is in line and true to the flats that we surface ground on the blade. This is where you run into a little bit of a problem, because you can see where those railroad track lines run off. This means that the distal taper I forged into the blade was not matched with the flats that we surface ground, meaning I got the surface grinding off a little bit, and while those are true and flat to each other, they were not started in the same plane as the distal taper. To do this right, I have to heat the blade up and straighten it to the now trued up surfaces that we surface ground, but that also means that we have to completely reheat treat the blade. I won't have to thermocycle it because we're heating it up well below critical temperature, but I do have to reharden it and retemper it before I can move on any further. I was able to complete these steps again within the same day and resurface grind it, get it back to the surface plate, and scribe lines, and we are quite close, pretty much good to go. Stay tuned for part 2, grinding the blade. It's going to be a good project. Thanks for watching. We'll see you on the next video.